Okay, today in IM1 we are going to be talking about graphing linear equations in slope-intercept form. So let's get going. Alright, so first of all we just reviewed slope. So now we're going to remember how to find slope, and that's what this page is all about. Remember that it's the change in y over the change in x, or you can call it rise over run, whatever helps you remember how to find it. Okay, so if we were going to find the slope of this line, we could use this point. Let's just take 2 points, and we could go -2 minus -2 over 4 minus 3. But then all of a sudden we get a 0, which we should have noticed right away that this was a y equals -2. It was a horizontal line which has a slope of 0. So hopefully you caught that. Okay, so here's another one. You can take your time to do this one. I want you to remember that it's any 2 points. So you can pick any 2 points. Maybe you want to pick the smaller number of points. I'm going to do these 2, and then I'm going to do 2 other points. So I'm going to go -13 minus -5 over 3 minus 1. Remember, it's the x minus the x. And always start with the same point. Okay, so that is a zip-zap, and we get -8 over 2 is -4. So let's try 2 different points. Let's try these 2 points. So I'm going to go 3 minus 11 over -1 minus -3. Zip-zap, 3 minus 11 is 8 over -1 plus 3 is 2. Whoops, and this is -8. So again, I get -4. It doesn't matter which 2 points on a graph you use or how far apart they are, it will always minimize to be the same slope. Okay, so when we're graphing in slope-intercept form, we want to use the slope-intercept form. This identifies what each part is. And it says any linear equation can be written in this form. So you can immediately see, if you always solve for y and simplify, you can immediately see the slope and the y-intercept. And you can quickly graph a line when it's written in slope-intercept form. Instead of doing a t-chart, you use the formula. You start here at this point, and then this one tells you how to move to the next one. Now, the one important thing about slope is that you always want it in fraction form. So this would be my rise, this would be my run. So I always do the rising first when I'm doing slope. So I'm starting from a point, I would go up 2, and then I like to go right 3, and then that would be my next point, and I would draw my line with my ruler. So that is a really helpful way to do it. I always run to the right. Okay, I run right. But what if I had a negative? So if there's a negative, I'm going to put the negative on the top. And instead of starting here, instead of going up, I'm going to go down. 1, 2, and then I'm going to run right. 1, 2, 3. Notice that changes to give me that negative slope that I needed. Okay, so that's one hint on how to do things. I always give the negative to the rise or run. If you run out of room on a problem, for example, if you had a graph that went all the way down to the bottom, and we'll look at one of those later, then you're going to have to go backwards, and we'll talk about that when the time comes. But this is a really good way to think of it if you always run right, like this. Run right. Okay, so graphing a line using slope-intercept. So I'm going to let the computer do the work for me on this one. So the first thing I do is I mark my point at my y-intercept. So there it is. And now I'm noticing that it's a down 2 over 5. So I'm going to go, it's a negative slope, so I'm going to go down 2, and then I'm going to go right 5. So down 2 over 5. And then the last thing you're going to do, verify your direction. And the man's running right. So draw a line through the 2 points, and there you go. Notice the line is nice and straight. Make sure you use a ruler. Okay, so I'm going to try to give you a few different situations on how you would graph. So we're going to start with a negative y-intercept, so that's down here. This is telling me that my rise over my run is 2 over 3. So I'm going to go up 2 and to the right 3. So I'm going to go up 2 and 1, 2, 3. And then you can do it twice if you want. You're going to go off the chart, but either way. And then you're going to use a ruler. I can't do that here, so there is what your graph should look like. Okay, over here we have a positive y-intercept of 2. And this time I have a rise over run of, I'm going to put the negative with the 1. And then I have 4. So I'm going to go down 1. And I'm still going to go to the right 4. Okay, so I'm going to go from that point down 1 over 1, 2, 3, 4. And there's my second point. And so my graph should look like that. Okay, now this last one I gave you specifically so that it would cause a problem. So we're going to go to negative 5 for our y-intercept, but this one says I need to go down 1, okay, down 1 because it's negative 1 over 3, and then right 3. But I can't go down 1. I ran out of graph. So you have to do things backwards. So I'm going to go up 1 and left 3. You have to do the opposite, okay? So I'm going to go up 1, left 1, 2, 3, draw a line, and then I'm going to look at that and I'm going to say, okay, is that 1 over 3? It is. And is my slope negative? And it is. I'm running and I hit my head, so it's a negative slope. So that's what your graph would look like for this one. So remember, if you run out of graph, you have to reverse both of them if you're used to going right. Okay? Just a hint. All right, so remember that any integer, so any whole number integer can be written as a fraction. This is not a whole number, but any integer can be written as a fraction with a 1 in the denominator. When you're moving rise over run, it has to have a denominator. Okay, because if I just kept moving down 2, I would have a vertical line. But this is not a vertical line, so I have to put the 1 there. So I go down 2 over 1, down 2 over 1, and I get a slope. Okay? All right, so let's graph this one. And first thing I'm going to do is I'm going to put the y-intercept on there, and I'm going to go up 2 over 1. Okay, this is over 1. And then I'm going to draw my line. There you go. Okay. Okay, so I included this problem from your journal in here because I thought it was very weirdly worded and very confusing. So I just wanted to give you a heads up if you get a problem like this on your homework. So there's a model, it's a function, so we can just go ahead and say, okay, y equals mx plus b. Okay, and it says the dependent variable, so remember your slope is your rise over your run, which is the change in y over the change in x. And now it's telling you what's happening. So the dependent variable, which is your y, is decreasing 6 units for every 3 units, and read it all, that the independent variable decreases. So all of a sudden they're saying they're both decreasing, and therefore my slope is 2. Okay, so now I'm going to go y equals 2x, and then the next sentence says the value of the function at 0 is 4. They're giving you the y-intercept. So I can say plus 4. Okay, so that is my equation. I'm going to mark that here. Then I'm going to do my rise over my run. Oh, I ran out of graph. So remember, if I'm going up and to the right, then I'm going to go down and to the left. So I'm going to go down 2, left 1, down 2, left 1. And there is 2 points, more points, and I can draw my graph. It's going to look something like that. My slope is, we found that out, is 2. My y-intercept is 4, and my x-intercept, which I found by doing the slope, is -2. And you can always find another intercept if it's a whole number, by just doing the slope from a point. Okay, so let's check it out. And we were right on. Okay? All right. So we're going to do a couple problems from the text, just to give you a little bit of information. So it says the table shows the amount in hours of the time you spend at a theme park and the admission fee in dollars. The points represented by the table lie on a line. So they're telling you it's linear. Okay, and then they want you to find and interpret the slope of the line. Whenever you're given this kind of problem, look it over. Okay, so it's 6 hours, 7 hours, 8 hours. And what do you notice about the cost? The cost isn't changing because our admission fee is one charge. They don't charge you per ride here. It's not like the state fair. So here is your equation. You don't really put the dollar sign. It is a horizontal line. And if you were going to interpret the slope, you would say, here's their answer, there is no change in the slope, which means that you are charged the same admission fee regardless of how long you stay. So that's a little fancier than what I would have said. I would have just said they've charged you one time and then you're free to stay as long as you want. Okay? There's all sorts of ways to describe a situation. Okay, I included this problem about milk because it has some things to show you that might get confusing. So it says a linear function m models the amount of milk sold by a farm per month. So right away your brain might say, oh, it's per month. But then you look at this next sentence and it gives you your slope. It says the amount decreases, and the m is your y function. So it's decreasing 500 gallons for every dollar increase. So it's gallons sold per dollar. Okay? So if I was going to graph this, I would have gallons sold, and this is dollars. Okay? So it says graph m when the y-intercept is 3,000. Okay? So now let's look at the graph and see what kind of information we can get. They want you to find the x and y-intercepts. We've already got the y-intercept. And then they want you to interpret them. Okay, so we know that our y-intercept is 3,000, and if we go down 500 over 1, down 500 over 1, and we keep going, we will end up at 6, okay, for the x-intercept. So our y-intercept is 0, 3,000, and our x-intercept is 6, 0. And they really don't make a lot of sense, but in this frame of this problem, they probably make sense to farmers. So it says no milk is sold when the price reaches $6 per gallon. In other words, it's too expensive now. Okay, people aren't going to pay that kind of a price. That's what that's saying. So $6, nobody's going to buy any of their milk if they raise the price to $6. Then it says the maximum amount of milk sold is 3,000, but that's if the price is 0. And that doesn't make any sense at all because no one's going to give the milk away. So the thing probably really starts at when they charge maybe 50 cents per gallon, they'll sell around $27.50. Okay? But that probably won't give them any profit. So at some point they have to decide, they have to come up with a profit model that will tell them that they'll start making money here, and then they'll know what is the optimal price for them to charge. So I thought this was a really strange problem and weirdly worded, so I included it so I could explain some of the misconceptions that you might have. So that's the end of this video. So go and practice graphing and have a great day.